The grounding conductor for a site lighting circuit indeed needs to be the same size as the current carrying conductors. This requirement is explicitly outlined in the National Electrical Code, specifically in Article 250.66a. NEC Article 250.66 unequivocally states that the grounding conductor for a branch circuit must be the same size as the ungrounded conductors. This is not merely a suggestion but a mandatory requirement for ensuring electrical safety and compliance. Understanding the rationale behind this requirement is crucial for any electrician or electrical engineer. The grounding conductor provides a low impedance path for fault current to return to the source. This low impedance path is essential for quickly tripping a circuit breaker or blowing a fuse in the event of a ground fault. If the grounding conductor is undersized, it may not be able to handle the full fault current, potentially leading to overheating, fire hazards, and delayed tripping of overcurrent protective devices. The size of the ungrounded conductors, also known as hot wires or current-carrying conductors, is determined by the load they are expected to carry. The National Electrical Code dictates specific ampacity ratings for different wire gauges, taking into account factors such as insulation type, ambient temperature, and the number of conductors bundled together. When a fault occurs, the fault current will attempt to follow the path of least resistance back to the source. The grounding conductor serves as that path of least resistance. To ensure that the grounding conductor can safely handle the fault current, it must be sized appropriately relative to the ungrounded conductors. By requiring the grounding conductor to be the same size as the ungrounded conductors, the NEC ensures that the grounding path has sufficient capacity to handle the maximum potential fault current. This provides a critical layer of protection against electrical hazards. Now let's delve into the specifics of NEC Article 250.66 and its implications for site lighting circuits. Site lighting circuits typically involve running power to outdoor lighting fixtures such as parking lot lights, street lights, and building perimeter lighting. These circuits are often exposed to harsh environmental conditions including moisture, temperature extremes, and physical damage. As such, it is especially important to ensure that the grounding system is robust and reliable. NEC Article 250.66 applies to all branch circuits, including those used for site lighting. This means that the grounding conductor for a site lighting circuit must be the same size as the ungrounded conductors supplying the lighting fixtures. For example, if a site lighting circuit uses number 12 American wire gauge copper conductors for the ungrounded wires, the grounding conductor must also be number 12 American wire gauge copper. Similarly, if number 10 American wire gauge aluminum conductors are used for the ungrounded wires, the grounding conductor must also be number 10 American wire gauge aluminum. It is crucial to note that the grounding conductor must be sized based on the size of the ungrounded conductors, not the calculated load of the lighting fixtures. Even if the lighting fixtures draw only a small amount of current, the grounding conductor must still be sized according to the ungrounded conductor size. This is because the grounding conductor must be able to handle the maximum potential fault current, which can be much higher than the normal operating current. Furthermore, it is important to consider the type of grounding conductor being used. The NEC recognizes several types of grounding conductors, including equipment grounding conductors and grounding electrode conductors. Equipment grounding conductors are used to connect the non-current carrying metal parts of electrical equipment, such as lighting fixtures and enclosures, to the grounding system. Grounding electrode conductors are used to connect the grounding system to a grounding electrode, such as a ground rod or a metal water pipe. For site lighting circuits, the equipment grounding conductor is typically run along with the circuit conductors in the same raceway or cable. The equipment grounding conductor must be sized according to NEC Table 250.122, which specifies the minimum size of equipment grounding conductors based on the size of the overcurrent protective device protecting the circuit. In many cases, the equipment grounding conductor will be the same size as the ungrounded conductors, as required by NEC Article 250.66a. However, in some cases, the equipment grounding conductor may need to be larger than the ungrounded conductors, depending on the size of the overcurrent protective device. The grounding electrode conductor, on the other hand, is sized according to NEC Table 250.66, which specifies the minimum size of grounding electrode conductors based on the size of the service entrance conductors. The grounding electrode conductor is typically connected to a grounding electrode system, which may consist of one or more ground rods, metal water pipes, or other approved grounding electrodes. The grounding electrode conductor must be sized large enough to effectively carry fault current to the grounding electrode system. In addition to the sizing requirements, the NEC also specifies requirements for the installation of grounding conductors. Grounding conductors must be securely connected to the equipment and to the grounding system. Connections must be made using approved methods such as grounding lugs, clamps, or connectors. Grounding conductors must also be protected from physical damage. They should be run in raceways or cables, or otherwise protected from abrasion, impact, and corrosion. It is also important to ensure that the grounding system is properly tested and maintained. Grounding connections should be periodically inspected to ensure that they are tight and free of corrosion. The resistance of the grounding system should also be measured to ensure that it is within acceptable limits. A high resistance grounding system can impede the flow of fault current, increasing the risk of electrical hazards. In summary, NEC Article 250.66 requires that the grounding conductor for a branch circuit be the same size as the ungrounded conductors. This requirement applies to site lighting circuits, ensuring that the grounding system has sufficient capacity to handle fault current and protect against electrical hazards. When designing and installing site lighting circuits, it is crucial to carefully consider the grounding requirements of the NEC and to ensure that the grounding system is properly sized, installed, and maintained. Ignoring these requirements can have serious consequences, including electrical shock, fire hazards, and equipment damage. Let's explore some specific examples to further illustrate the application of NEC Article 250.66 to site lighting circuits. Example 1. A site lighting circuit is designed to supply power to 10 100-watt LED lighting fixtures. This circuit is wired with number 12 American wire gauge copper conductors and is protected by a 20-amp circuit breaker. According to NEC Article 250.66a, the grounding conductor for this circuit must also be number 12 American wire gauge copper. The equipment grounding conductor, which is run along with the circuit conductors in the same conduit, must also be at least number 12 American wire gauge copper, as specified in NEC Table 250.122 for a 20-amp overcurrent protective device. Example 2. A site lighting circuit is designed to supply power to 4 400-watt metal halide lighting fixtures. The circuit is wired with number 10 American wire gauge aluminum conductors and is protected by a 30-amp circuit breaker. In this case, the grounding conductor for the circuit must be number 10 American wire gauge aluminum, as required by NEC Article 250.66a. The equipment grounding conductor must also be at least number 10 American wire gauge aluminum, as specified in NEC Table 250.122 for a 30-amp overcurrent protective device. Example 3. A site lighting circuit is designed to supply power to a single high-mast lighting fixture. This circuit is wired with number 6 American wire gauge copper conductors and is protected by a 50-amp circuit breaker. According to NEC Article 250.66a, the grounding conductor for this circuit must be number 6 American wire gauge copper. The equipment grounding conductor must also be at least number 10 American wire gauge copper, as specified in NEC Table 250.122 for a 50-amp overcurrent protective device. In this case, the equipment grounding conductor is smaller than the ungrounded conductors, but it still meets the minimum requirements of the NEC. It is important to note that these are just a few examples, and the specific requirements for grounding site lighting circuits may vary depending on the specific application and the local electrical codes. It is always best to consult with a qualified electrician or electrical engineer to ensure that the grounding system is properly designed and installed. Furthermore, it is essential to stay up to date on the latest revisions of the National Electrical Code. The NEC is updated every 3 years, and changes to the code can impact the design and installation of electrical systems. By staying informed about the latest code requirements, electricians and electrical engineers can ensure that their work is safe, compliant, and reliable. In addition to NEC Article 250.66a, there are other sections of the NEC that are relevant to grounding site lighting circuits. These include NEC Article 250.4, which covers general requirements for grounding and bonding, NEC Article 250.24, which covers grounding separately derived systems, and NEC Article 250.118, which lists acceptable grounding conductors and their installation requirements. It is important to be familiar with all of these sections of the NEC to ensure that the grounding system for a site lighting circuit is properly designed and installed. In conclusion, the grounding conductor for a site lighting circuit must be the same size as the current carrying conductors as required by NEC Article 250.66a. This requirement is essential for ensuring electrical safety and compliance. By understanding the rationale behind this requirement and following the guidelines outlined in the NEC, electricians and electrical engineers can design and install site lighting circuits that are safe, reliable, and code compliant. Always consult with a qualified professional and stay informed about the latest code revisions to ensure the best possible results. Remember, electrical safety is paramount, and proper grounding is a critical component of any electrical system. Adhering to the NEC requirements for grounding conductors and site lighting circuits is not just a matter of compliance, it is a matter of protecting lives and property. The National Electrical Code serves as a comprehensive guide for safe electrical installations, and its provisions regarding grounding are designed to minimize the risk of electrical hazards. By following these guidelines and prioritizing safety, we can create a safer and more reliable electrical environment for everyone. Therefore, when working on site lighting circuits, always remember the importance of proper grounding and the specific requirements of NEC Article 250.66a. Your diligence and attention to detail can make a significant difference in preventing electrical accidents and ensuring the safety of the public.